By the end of this video, I'll expect you to understand how to check for overidentification and how to fix it. Previously, we found tiebreakers in 2 examples, and in each example we ended up with 3 identifying descriptors. Whenever we have 3 identifying descriptors, it's a good idea to ask some questions to make sure we're not over-identified. It's possible that one of the original 2 identifying descriptors we started with, before adding the tiebreaker, did not actually need to be part of the identifier at all. That is what we will look for in these examples. We reached both examples as a result of seeking a tiebreaker. In both cases, the next step is to consider overidentification. You can see there are 4 possible outcomes from this exercise. From the 3-way intersection entity, we might return to another 2-way intersection entity with descriptors, or we might reject overidentification. From the 2-way intersection with tie-breaking attribute, we might evolve to a dependent entity with chicken feet in, or we again might reject overidentification. We'll go over all 4 of these outcomes in this video. The burning question? We just got to the 3-way intersection entity, and now we're going back to another 2-way identifier? Are we going to be locked in an infinite loop, a never-ending battle of good against evil? Launch the X-Wing fighters. For this next exercise, consider this LDS fragment around entity X. About entity X, how many of each of these does it currently have? Links, attributes, descriptors, identifying descriptors. I'll give you a moment and pause. Alright, the answers are 2 links, A and B, 2 attributes, C and D, 4 descriptors, A, B, C, and D, and 3 identifying descriptors, A, B, and C. Notice that D is not included in the identifier. This will be in our next example. Next question is true or false. X is a 2-way intersection entity. Well, the answer is true. Notice this has exactly the same shape as inclusion and collection after we had added the sequence number tiebreaker. This is a 2-way intersection entity with tiebreaker attribute C. Here I've represented our 4 descriptors, A, B, C, and D, as circles. For identification issues, it does not matter if these are links or attributes. They're just descriptors. Our goal is to figure out which descriptors should be included in the identifier. As of now, recall that A, B, and C are included in the identifier, and D is not. Is that the best answer? Do all 3 of these belong in here? Let's look for ways to reduce the identifier. We'll do this in a controlled and scientific way, checking each identifying descriptor one at a time to see if it can be removed from the identifier. Each potential removal can be tested. We test by asking the tiebreaker question. For example, let's hypothesize that descriptor A is not part of the identifier. The way we test that hypothesis is to look at the remaining descriptors B and C and see if those 2 hold up on their own as an identifier. So we ask, can 2 instances of X have the same B and C? Didn't have to mention the A. If the answer is no, then we've validated our hypothesis and we can actually remove A from the identifier. If the answer is yes, then the test is inconclusive. It doesn't necessarily mean that A should be part of the identifier, but it can neither confirm nor deny either way. And the safest thing to do is to leave it there until we get more information. Let's assume that the answer is yes, you could have 2 X's with the same B and C. That means B and C are not enough on their own. We might still need A. So let's leave A included in the identifier and move on to testing B. A hypothesis that B can be removed leaves A and C included. So we ask the users, can 2 instances of X have the same A and C? Suppose this time the answer is no. That means that we've validated our hypothesis, and A and C stand alone as an identifier. Now we have returned to a 2-part identifier. So we will now remove B from the identifier for X. Notice now that only one of the links on X has a bar. This means X is no longer an intersection entity. This is now called a dependent entity. We will explore this further in future videos, but here's a conceptual overview. X is called dependent because each instance of X depends on an instance of A for its identification. We've not yet established an identifier for A, so it's a little awkward to cover this in detail. For now, you can think of each X as belonging to an A and is therefore dependent on it. The attribute C distinguishes different instances of X, but C is only locally unique within an A and can repeat across instances of A. Let's apply this to a more concrete example. After finding that the sequence number was a tiebreaker, the next step in this example was to consider overidentification. We have 3 descriptors to consider removing. We can skip considering sequence number because we just added that one. Let's consider whether we can remove the bar on collection. We ask, can 2 inclusions in collection have the same photo and sequence number? Yes. Unlikely, but a photo can be photo number 1 in more than one collection. Yes means inconclusive, so no action, no change. Next, let's consider removal of the bar on photo. Can 2 inclusions in collection have the same collection and sequence number? No. A collection like cats cannot have more than one photo number 1. That would call into question the meaning of the sequence number. No validates that we can remove photo from the identifier. And now, just like entity X, inclusion in collection has become a dependent entity because of its 2-part identifier structure, one on a link and one on an attribute. Inclusion in collection still has a photo. Each inclusion in collection can have a photo, but the photo is no longer used to identify the instance. Chapter 26 of Mastering Data Modeling lists many different recipes, which are fragments of a data model that appear frequently in the real world. You can see that our photo collection model follows the recipe of fragment 26.4 exactly in terms of chicken feet and bars. The names are different but serve the same purpose. Study these fragments for yourself and see if you can explain in your own words why our middle entity ended up with only 2 bars and why one of its links has a bar and the other does not. Returning to the flowchart, you can see from what we've discussed that we've reached outcome number 3 here. Dependent entity with chicken feet in. We determined that yes, it was over-identified with all 3 bars, and we really only needed 2. If we'd checked all 3 descriptors A, B, and C, and the users confirmed that all 3 really did need bars, then we would reject over-identification and move on to outcome number 4. We follow exactly the same process for outcomes 1 and 2. The only difference is that all 3 descriptors happen to be links in that case. Let's check your understanding by applying what we learned to a 3-way intersection entity.